Assalamualaikum and hello there. So in this video I'm going to do a demonstration for lab 2, which is arithmetic equation and operation. So read this question 1. So for question 1, there is the code that I copy from the lab manual. So here we declare variable var1 and var2. var1 is 1 and var2 is 9, and then we are going to do this one by one. So I already rebuilt it, so let's just debug. Okay, so they're gonna show an output, but let's proceed forward. And so when we debug it, it's going to show the register and also the memory. Wait a second. Okay, so first let's look for var1 first. Address for var1, and var1 actually here. This is var1, and var2 actually is right here. So first here it says move AX var1. It means that we want to set copy value of var1 to AX. So when we here we can see it is right now is 0001, and then when we do it again, so for the line 2 it's set bx to var2, which is 9. So we can see here it's now bx is 0009, and then next for line 3, it says exchange ax and bx. It means that we exchange the value of ax and bx. So right now ax is 0009, which is before this is 0001, and bx right now is 0001. That before this is 0009. So for line 4, actually we move the value of register ax into var1. As you can see, before this var1 is ax is 0009. So we can see here the address of var1 right now have been moved with value of ax, which is 09. And then lastly we move var2 to bx. It means that we move the value of register bx into var2. As you can see here, var2 bx, before this bx is 0001, so right now var2 is 01. And then so that's all for question 1. So for the next question 2, I also copy this from the lab manual. That is, we are going to do arithmetic expression, which is r val equals to negative x val plus y val minus z val plus 1. So there is the value for x val, y val and z val, and there is the code that we are going to do. So I already rebuilt and debug it. So let's see one by one, line by line. So let's search for x val first. Let's search for x val. Let's second x val. So x val right now is 1a. This one is in hexadecimal. This one is actually is in decimal. So for line 1, let's see. So for line 1, it's actually move EAX with x val, which is 26. So we can see here EAX right now is 1a, And then next, right now we want to move EBX which rival. So right now EBX um, EBX right now is EBX right now is the same as rival. And then uh oh sorry, so for line 2 tadi, actually it's negation EAX. So what happened here, we negate, we negotiate, we might, we change the we change the positive to negative. So from positive 26 we change it to be negative 26. And then for line 3 we move EBX rival line 3. So right now EBX right now is 1E which is 30. And then for line 4 we subtract EBX with Z val line 4. So right now we got EBX is F 6. And then for line 5 we want to add EAX with EBX. So right now EAX is DC. And then we want to increment EAX with line 6 in line 6. So we got EAX FFFFDD. And then we want to move we want to copy value of AS into R in line 7. So let's see, we can see the value of R is right now is the same as AS. Maybe we can look for it. Oh, this one, FFFFFFFFDD. So this one is the address for R is the same as AS. Okay, so for the next question, which is question 3, so we are going to do this code. This is based on the arithmetic expression, which is bar 4 equals to bar 1 multiplied by bar 2 and plus bar 3, and then we are going to minus it with 1. So this is also, I copied it from the lab manual, and here we can see that first bar 1 is 5, bar 2 is 10, bar 3 is 20. Here we can see that I already said bar 1 is 5 here. This is the address for bar 1. So we are going to do it line by line. So let's first, so for the first line we move EAS with bar 1 which is 5, and here we can see EAS right now is 5. And then for the line 2 we multiply bar 2, we multiply the value, multiply EAS with bar 2 actually. So we got 32. 32 here is actually is hexadecimal. In decimal we got 50. And then for the line 3 we add EAX with var 3 which is 20, and we get 46. So in decimal we actually get 70. And then for the last one we decrement EAX with EAX, which is we minus it with 1 decrement. So EAX right now is 45. Before this it is 46, right now is 45. So in decimal actually 69. So when we exit, and then that's all for question 3. So for question 4, it is another arithmetic expression, which is var 4 equals to var 1 multiplied by 5 and divided by var 2 minus 3. So this is the code, this is code. And then here we have var 1, var 2 and var 4. Var 1 is 40, var 2 is 10. So first let's look for address. Let's look for bar 1 first. Okay, 40 in hexadecimal is 28, so it's right. So in bar, so for the first line, so let's we move AX with bar 1. So right now it should be AX with bar 1. So here AX is 28, bar 1 is 28, and then BX 5. So we set BX to 5, and then we multiply BX with AX. So right now we got AX is C8 and BX is still 5, and then we move BX with var 2. So BX right now is A, var 2 is 10. So if we look for var 2, so here var 2 is A, and then we subtract BX with 3. So right now BX is 7, 10 minus 3 is 7, and then we want to divide BX with AX. So right now AX we get 1C, and BX is still 7, and then DX we got, here we got DX is 4. So we want, and then for the last one we want to move var 4 to AX. So you can see var 4, if we look for it, var 4 here, var 4 is actually 1C. We got 1C, and then X also 1C. Okay. So that's the end of the program of question 4. So now I'm going to demo question 5, which is the code snippet already been given in the lab manual, and I'm just copy it. So it is actually multiple of CX. So we are going to look at it line by line. So right now we are in line 6. So if after that in line 6 we actually move the X. Actually we want to move the X with 0, so we clear the X here with 0. So right now the X is 0, and then we want to move X with value of 1000. So here X right now is 1000, and then we want to move CX with 25. So CX right now is 25, and then we want to multiply X by CX and store the result in the X. So right now in the X, we can see right now the X is 2, and then we are going to call the down register here. This is the down register, and that's all for question 5. So for the last question, which is question 6, here is the provided code snippet from the lab manual, and just copy it. So we are going to go through it step by step. So first we are going to move the X with 0, which is we are going to clear the X, and we are going to set it to 0 right here, and then we are going to move X with 803, and then here add speed 803, and then we are also going to move BL with 10. So BL right now is 10, and then we're going to divide BL. So divide yes by BL, whereby x actually is the quotient and dx is the remainder. So here we got 380, 380. So then we call the register. Here this is the down register. Okay, that's all the situation for lecture, and that's all from me. Thank you.